Hello and welcome to another marathon. Today's topic is hypothesis testing of the population mean or using normal distribution. And let's jump into the questions. This is part of the S2 syllabus. If you are attempting S2, that's what you should be practicing. Um, okay, let's see. Question number one says in the past, Arvinder has found that the mean time for his journey to work is 35.2 minutes. He tries a different route to work, hoping that this will reduce his journey time. Arvinder um decides to take a random sample of 25 journeys using the new route. If the sample mean is less than 34.7 minutes, he will conclude that the new route is quicker. So he has this rejection region in front of him. So rejection region is x is less than 34.7. He will conclude that the new route is quicker. Assume that for the new route, the journey time has a normal distribution with standard deviation 5.6. So I have sigma equals to 5.6. Okay. Find the probability of a type 1 error. So type 1 error is basically the significance level or the rejection region. So I'm going to say that type 1 error is probability of rejection region. I think that's simple to calculate. It's for I'm going to say that this is converted into Z. I'm going to subtract the population mean, which is 35.2, and divide it by sigma divided by root n. So 5.6 divided by root of 25. Okay, let's see what I get. 34.7 minus 35.2. 5.6 by 5. I get probability of z less than minus 0.446. So this becomes 5 minus 0.446. 1 minus 5, 0.446. I can use my calculator to find out phi. If you don't already know that, I have videos explaining that. You can go to the classless videos and find this out. This is the new classless calculator. I'm going to calculate on this. I can see distribution in front of me. I am going to say that I want to go to the normal cumulative distribution. Since I am calculating phi, I'm going to put in minus 10 as the lower and then 0.446 as the upper, and mu is 0 and sigma is 1. Sigma is 1. Okay, let's execute. So I get 1 minus 0.6722. Okay, that value might differ a little from the table. If you were reading the table, it might be a decimal rounding off, which is fine right now because I'm teaching you how to use a calculator. 1 minus 0.6722, and that's 0.3278. Your final answer will of course be correct, 0.328. That is the correct answer here. It says Arvinder finds that the sample mean is 34.5. Explain briefly why it is impossible for him to make a type 2 error. Okay, now his rejection region was x bar is less than 34.7. If his sample mean was 34.5, 34.5 is inside the rejection region. Therefore, H naught is rejected. When you reject H naught, there's a possibility of making a type 1 error, not a type 2 error. Type 2 error is when you accept H naught. So cannot make a type 2 error when H naught is rejected. Okay, that's the first question. 5 marks. Let's move on to the next one. It says the marks of candidates in mathematics and English independently um, represented by the independent random variable x and y with distribution this and that. Each candidate's marks were combined to give a final mark f. where f equals to x plus half of y. So the y marks have been scaled, so we'll have to apply linear combination of variables and see where that goes. Find the expected value of f. Okay, so f is basically expected value of x plus half of expected value of y. Okay, so I get 28 plus half of 52, 54. Okay, variance of f is variance of x plus half square variance of y. Those are the rules for linear combination of variables. 12.4 squared, yeah. So I have 5.6 square plus 12.4 square over 4, 69.8. Okay, so those are the two answers. It says the final marks of a random sample of 10 candidates from Greenfield in May 2009 had a mean of 49. Test at the 5% significance level whether this result suggests that the mean mark of all candidates from Greenfield in 2009 uh, was lower than elsewhere. Okay, so mu was initially 54 for us, according to the previous part. And H1 is then what I'm trying to test is if the mean uh, had reduced. Okay, okay. Then I'm going to say that I have to draw my rejection region first. This is a 5%. So I will read my calculator for 95% inverse normal. Okay, let's do that on screen. Distribution inverse normal 0.95. Okay, and execute. So 1.645. So minus 1.645 since it's on the negative side. Okay. So then I calculate the z value of my test statistic. So that is going to be x bar minus 54 divided by, I have 69.8, so I'll have to root that 2 and divided by root of 10. Okay, 49 minus 54 divided by root of 6.98 basically. I'm getting minus 1.893. That is inside my rejection region. So H naught is rejected, which means that the population mean has fallen, is rejected. Population mean might have decreased. But according to the question, what is it is asking me is that tested the 5% significance level whether this result suggests the mean marks of all candidates from Grinford. So Grinford in 2009 was lower than elsewhere. Okay, so yes, the mean marks were lower. The only thing is that this question doesn't say anything about Greenford. So there were just 10 candidates. Let me just check the marking scheme for this one so that we are absolutely sure of what's going on. November 10. So I think question number 5, if I'm correct. Okay, so this just says that Greenford mean is lower. I think the question is missing a little bit of context. Since it doesn't say what data I had initially, whether I had data from Greenford or not. I think this is missing a little bit of context here. Okay, but since we've rejected H naught, we've concluded that the population mean has decreased. Okay, moving on to the next question. This is question number 3. The number of hours that Mrs. Hughes spends on her business in a week is normally distributed with mean mu and standard deviation 4.8. In the past, the value of mu has been 49.5. So that is basically my H naught. Assuming that mu is still equal to 49.5, find the probability that in a random sample of 40 weeks, the mean time spent on her business in a week is more than 50.3 hours. So I'm just asking you to calculate the probability of X bar greater than 50.3. So X bar is going to have a population distribution that is normal with 49.5 and sigma divided by n, 40 weeks. Sigma square divided by n because you write the variance here. Okay, I'm going to take the root of this when I'm calculating the probability. So I want to calculate the probability of X bar greater than 50.3. So I'm going to say Z is greater than 50.3 minus 49.5 divided by 4.8 divided by root of 40. Hmm. I'm getting probability of Z greater than 1.054. So that gives me 1 minus 5, 1.054. I'm going to use the table this time. 1.054. So 1.05 and 4. So 8531, so 8540. 1 minus 0.8540, that gives me 0.146. Okay. Following a change in her arrangements, Mrs. Hughes wishes to test whether mu has decreased. She chooses a random sample of 40 weeks and notes that the total number of hours she spends on her business during this week is 1920. So I can then calculate X bar. I can say that X bar is the sum of hours divided by 40. So 1920 divided by 40. That gives me 48. So the sample mean has come out as 48. Explain why a one-tailed test is appropriate, because you want to just test whether mu has decreased. So it's a one-sided decision. Okay, looking for a decrease. Carry out the test. So whenever you're carrying out the test, you first write your null hypothesis. Mu is equals to 49.5 was the initial thing, and I'm looking for a decrease. And then I draw my significance level. So I will have to look at 94% from my table. I go inside my table and look for 94 or as close to 94 as possible. I think 9394 plus 6, so that gives me 1.555. So minus 1.555. Then I calculate the z value of my test statistic, which is 48. So 48 minus 49.5 divided by 4.8 divided by root of 40. Okay, z value of test statistic is inside the rejection region. Therefore, reject H naught. Okay, there is evidence that H naught has decreased. That mu has decreased. Sorry, mu has decreased. Okay, there is evidence that the mean has decreased. Okay, then it says explain whether it is necessary to use the central limit theorem. So you don't use the central, you use the central limit theorem when the population is not normally distributed. So you don't use it here. You just say that you don't use the central limit theorem because it is normally distributed. Okay, moving on to question number 4. It says the height of a certain type of plant have a normal distribution. This when the plants are grown without fertilizer, the population mean and standard deviation are 24.0 and 4.8 respectively. A gardener wishes to test at the 2% significance level whether hydro fertilizers will increase the mean height. Okay, so I am testing for an increase. So mu equals to 24.0 and H1 should be greater than 24.0. I don't know what I have to do, but I'm just writing down the information. He treats 150 randomly chosen plants with hygrofertilizers and finds that the mean height is 25.0. So sample mean comes out as 25.0. Assuming that the standard deviation is still 44.8, carry out the test. So it's a 2%. So I'm going to have go and look at 98% inside the IC 9798, 2.05, and I need 2.054 or 0.055. That's your choice. You can use a calculator to be more precise. 2.054. I'm going to write 0.054. Probably not going to be very close, depending on the question. So z value of test statistic then 25 minus 24 divided by 4.8 divided by root of 150. It gives me 2.552. Okay, so that's pretty high in the rejection region, so that's fine. So in the rejection region, reject H naught. Except there is evidence that hygro increases height. Hmm. Okay. Question number 5. The management of a factory thinks that the mean time required to complete a particular task is 22 minutes. Okay, so that's what they think. The time in minutes taken by employees to complete this task have a normal distribution with mean mu and standard deviation 3.5. An employee claims that 22 minutes is not long enough for the task. In order to investigate this claim, the time for a random sample of 12 employees was used to test the null hypothesis against the alternate hypothesis at the 5% significance level. This is going to be 1.645. That is what I know from my table as well. I sort of remember the values now. Okay. Okay, the 5% significance level. Show that the null hypothesis is rejected in favor of the alternate hypothesis if x bar is greater than 23.7, correct to three significant figures where x bar is the sample mean. So what I need to show to you is that any x bar greater than 23.7 will be rejected. So my rejection region is basically x bar is greater than 23.7. That is what I have to come up with. Right now, I see my rejection region in terms of z. Okay, but I don't need z, so I'm going to change this x 1.645 into a value for x bar. I'm going to say that minus 22 divided by sigma 3.5 divided by root of 12. So I've converted a z value into an x bar value, and I'm going to say that this becomes 1.645 into 3.5 divided by root of 12 plus 22. So I'm getting 23.662. So the rejection region is x bar is greater than 23.7, correct to three significant figures. Okay, that's what it says. Find the probability of a type 2 error given that the actual mean is 25.8. Okay, so probability of type 2 error is basically probability of acceptance region using nu mu. So acceptance region is now x bar is less than 23.7. If greater than 23.7 was your rejection region, then less than 23.7 should be your acceptance region. Okay. Converting this into z, I'm going to use the new mu now, which is 25.8 divided by sigma over root n. Sigma is still the same, and 12. So I get all of this, then go to my table 2.078. This table is acting weird. Nine eight one two 0.9812 0.0188. So the probability of a type 2 error is it's different for, let's see what we've done if we've calculated something wrong. Okay, I think I did not write the standard deviation correctly. Hmm. 0172. There is a small error there. Let's find out why that is the case. 078. Let's check our working. Okay, that's fine. Where did I make a mistake then? Okay, let's go back and check for our marking scheme. November 11/7/2. Let's check where we made a mistake. Hmm. Okay, so it is more of a rounding off error that I seem to have carried forward. I have used 23.7. I should have used 23.662, and that should give me the correct answer. Okay, I think there should be a tolerance in the question as well, where it says that it's acceptable. So I am going to get this mark. I am going to get this mark as well, and I'm going to get this mark as well. So I think we are clear. It doesn't. It's not a problem if I got that answer. Okay. So I'm going to reverse my working. But the idea is if you have a rejection region that's more precise, use that one. Question 6. In the past, the flight time and average for a particular flight has a mean of 6.20 and standard deviation of 0.80. Some new regulations are introduced in order to test whether these new regulations have had any effect upon flight times. The mean flight time for a random sample of 40 flights is found. State what is meant by a type 1 error in this context. So let's first write our H0 and H1 so that we know exactly what the question is asking. In order to test whether the new regulations have had any effect on flight time. So I'm not giving you a direction, I'm just going to say that it's H1, that mu is not equals to 6.20. So type 1 error is when you reject H0 when H0 is true. Okay, so in this case, concluding that flight times have changed when they have not, when in reality they have not. Okay, so that's the answer. The mean time for a sample of 40 flights is found to be 5.98. Assuming that the standard deviation of the flight time is still 0.80 hour, test at the 5% significance level whether the population mean flight has changed. This is a two-tailed test, so 2.5% on both sides. I'm going to use my table to read 97.5% now. So 975 is 1.960. So minus 1.96 and 1.96. Okay. Then I calculate the z value of my test statistic. So equals to x bar minus mu or sigma 0.8 to 10 40. Minus 1.739. Okay, that is not in the rejection region. Minus 1.739 should appear somewhere here. So not in the rejection region, in the acceptance region. So accept H naught. Flight times have not changed. Okay, state with the reason which of the errors type 1 or type 2 might have been made in your answer. So whenever you accept H naught, type 2 errors can be made. because type 2 error is the error of accepting H naught when H naught is false. Okay, so H naught was not rejected, therefore type 2 error. Remember that the marking scheme will always say that you don't use the word accept, you say not reject. Okay, because that is how hypothesis testing is designed. Okay, question number 7. A researcher is investigating um, the actual length of time that patients spend with the doctor at their appointments. He plans to choose a sample of 12 appointments on a particular day. Which of the following methods is preferable and why? Choose the first 12 appointments of the day or choose 12 appointments evenly spaced throughout the day. So the second method is more acceptable. Why? Because it gives equal chance, relatively equal chance to people appearing throughout the day. Relatively equal chance. Okay. Appointments are scheduled to last 10 minutes. The actual length of time in minutes that patients spend with the doctor may be assumed to have a normal distribution with mean this and standard deviation that. The researcher suspects that the actual time spent is more than 10 minutes. Okay, to test the suspicion, he recorded the actual times for the random sample of 12 appointments and carried out a hypothesis test at the 1% significance level. State the probability of taking a type an error and explain why is what is meant by a type 1 error in this context. Okay, so first I'm going to write my H naught. Mu is 10 and H1 says mu is more than 10 minutes. Actual time is spent more than 10 minutes. Okay, so in this case, the type 1 error, probability of type 1 error is basically the significance level, which is 1%. So probability is 0.01. You make a type 1 error when you reject H naught when H naught is true. So in this context, it means concluding that time spent is greater than 10 minutes when it is actually not. Okay, so that was part 2. Part 3, given that the total length of time spent by 12 appointments, so x bar is then 147 divided by 12. 147 divided by 12. That gives me what? Gives me 12.25. So carry out the test. So I need this to carry out the test. I am going to draw my rejection region. Um, 99% is what? 2.326. So z value of test statistic is 12.25 minus 10 divided by the standard deviation was 3.4 divided by root of 12. Hmm. Giving me 2.292. That is not in the rejection region. 2.292 is somewhere here. Okay, so except H naught, mean times are the same. Okay, no reason to believe that the appointments are too long. Give a reason why the central limit theorem was not included in part 3 because it already says it's a normal distribution. Okay, so the population is normal. You use the central limit theorem when the population is not normal. Right now it's normal. Okay, question 8. The weights x kilograms of bags of carrots are normally distributed. The mean of x is mu. An inspector wishes to test whether mu equals to 2.0. He weighs a random sample of 200 bags, and these results are shown in the carry out the test at the 10% significance level. Okay, so mu is equals to 2.0. An inspector wishes to test whether mu is equal. So it's a two-sided test, and I'm not giving you an increase or a decrease. So H0 and H1 are like that. I am going to draw my rejection region first. I have 5% on both sides. That gives me 1.645 and minus 1.645. Now I don't have X bar, so I'm going to say 1290, oh, sorry, 430 divided by 200. 2.15, and then sigma square. So n over n minus 1 into the working for the standard deviation, which is 1290 divided by 200 minus 2.15 squared. So I have sigma square equals to 1.837. Okay, both of these going to go inside a root. So 1.565. Again, not in the rejection region. Okay, um, except or not enough evidence that H naught has changed. I don't know, it's not working. Okay, so that's done. You may now assume that the population variance of X is 1.85. The inspector weighs another random sample of 200 bags and carries out the same test. At the 10% significance level, state the meaning of a type 2 error in this context. So a type 2 error is when you accept H naught when H naught is false. So you concluding that the mean weight is 2.0. Mean weight is when it is not. Okay, that is in the context. Given that mu equals to 2.12, so the new mu is 2.12. Show that the probability of a type 2 error is 0.652, correct to three significant figures. So probability of acceptance region. Now the interesting thing about this question is that you don't yet have the rejection region. So what I will have to do is go to the previous part, take these z values minus 1.645 and 1.645 and convert these to values of x so that I can state my rejection region. Okay, so I am going to say that if I want to convert these, and you see the variance is also changed. So I'm going to say that the rejection region was x bar minus from the previous question 2.0 divided by 1.85. I don't know why this was 1.85. Gonna do a calculation mistake at 1.84. It's okay, we can check later. I think we've gotten the right conclusion. So there might be a slight difference in calculation maybe, but I'm going to check that later on. 1.85 divided by root of 200. Okay, this was the standard variance. So I'm going to put that inside a root as well. Okay, let's see what I get. What I'm trying to do here is I'm going to find the rejection region first and then convert it into an acceptance region and then calculate the probability of that, because it is a 7-mark question. So you will have to do all of that. X bar is 1.842. Okay, the rejection region comes from the previous part and then you convert it into an acceptance region. I hope we get the correct answer. Bar equals to 2.158. So the rejection region is from 1.842, less than 1.842 and greater than 2.158. So the acceptance region is going to be x bar is between 1.84 and 2.158, and I'm going to use the new mu to calculate the probability of this. 1.842 minus, what's the new mu? The new mu is 2.12. Okay, that's what's given in the question. And I have then root of 1.85 divided by 200. One 1.842 minus 2.12 divided by root of 1.85 divided by 200 minus 2.891. 0.395, 5.395 minus 5 minus 2.891. I seem to be running out of space here. 0.395. Let's quickly go on to our sheet. 395, 6536. 2.891, a large number. Nine, okay, 9981. Okay, 0.6536 minus 1 point is 0.9981. I think my answer is pretty close, 6.6517, and that rounds out to 0.652. Okay, you can go back, scroll back on the video and solve the question again and see if you get the correct answer as well. It's a long question. You see, your exam has a large chunk of marks. invested here. So that's 14 marks invested here. Make sure that you do this correctly. Question number 9. The masses of packets of cornflakes are normally distributed with mean with standard deviation 11. A random sample of 20 packets was weighed and found to have a mean mass of 746. Test at the 4% significance level whether there is enough evidence to conclude that the population mean mass is less than 750. The original must have been 750, and I'm testing whether it's less than 750. Let's draw the rejection region. 4%. Let's read off 96% from here. 96%. 1.75 and 1. Okay, so z value of test statistic 746 minus 750 divided by 11 over root 20. Minus 1.626. So that is again not in my rejection region. So except it failed to reject. Not enough evidence to conclude that mean is less than 750. Okay. Part 2, given that the population mean was actually 750 grams, find the smallest possible size n for which it is at least 97% certain that the mean mass of the sample exceeds. Okay, so in this case, I am asking you, given that the population mean mass is actually 750, so it's the same. What I'm asking you is find the smallest possible sample size n. So I'm asking you for a value of n for which it is at least 97% certain that the mean mass of the sample exceeds 745. So I am asking you x bar is greater than 745 is equals to 97%. It's a simple sampling question rather than a hypothesis testing question. Okay, that's what's unknown. So I'm going to say that this becomes 1 minus phi of minus 5 over 11 root n equals to 0.97. 1 minus 0.97 equals to phi of minus 5 over 11 over root n. You can solve it in whichever way you want. If you want to simplify the minus and take 97% on the other side, that's absolutely fine. I'm going to use my calculator to do that. And I'm going to say that I will get an answer that is negative. So what's inverse normal? Minus 1.881. Okay, and I'm also going to solve this directly on my calculator. Okay, there was though at least. So at least should mean this. Greater than or equals to, greater than or equals to, greater than or equals to, greater than or equals to. when I cancel this, it's going to flip the sign as well. Okay, and then I can solve. So I'm getting n is greater than or equals to 17.12, therefore means n is 18. Let's quickly go on to the last question. It's been a long marathon for this one. Metal balls are produced in large number and have lengths which are normally distributed with mean this and standard deviation that. Find the probability that a random sample of 45 balls will have a mean length of more than 2.55 centimeters. Okay, so x bar is greater than 2.55. So z 2.55 minus 2.62 over zero point 0.3 divided by root of 45. Okay, then let's calculate the probability. It's 1 minus 5 of that. So 1 minus 1 minus 5, 1.565. It's 5, 1.565. 1 and 1 will cancel out. 0.565. 9412. Okay, that's the answer to the first part. Then there's the machine these bolts are making these bolts is given an annual service. This may change the mean length of bolts. Produced but does not change the standard deviation. To test whether the mean has changed, a random sample of 30 bolts is taken and the length is noted. The mean sample mean length is m centimeters. Find the set of values of m for result which result in rejection at the 10% level that there is no change in the mean length has occurred. Okay, so no change. So I'm going to say that this is a two-sided, a two-tailed test. I have a 10% significance level. So 5% on both sides. Right now my z values are 1.645 and minus 1.645. So minus 1.645 equals to x bar minus mean over 0.3 divided by root of 30. So m should be find the set of values for which result in rejection. So rejection is when m is less than 2.53 or m is greater than 2.71. Those are the correct answers. I can see that from my diagram as well. That is the end of the first marathon. This was a long marathon. Please make sure to like, subscribe, and comment if you have questions. I will be back with another marathon for hypothesis testing using binomial and Poisson distributions as well. Thank you for watching.